So welcome to our first NAC Ask Me Anything of the spring 2024 semester. As you might know, my name is Burcin Becerik-Gerber. I'm an NAC member and professor and the department chair of the Sani Astani Civil and Environmental Engineering at the University of Southern California. And I usually co-moderate NAC with Susan Bogus, and who is a professor and chair of construction engineering and management at the University of New Mexico. She is busy today, so she might join us, but right now I don't see her here. So the NAC was established in 1999 to recognize our industry leaders. An important purpose of the Academy is to share collective knowledge and experience of our members to improve the industry. We have established NAC AMA to help transfer knowledge of our members to our next generation of construction leaders, with this webinar providing a means to link past and present participants in the construction industry. Our AMA sponsors this year are the University of Florida Rinker School of Construction, Arizona State University Del Webb School of Construction, and the University of Colorado at Boulder Construction Engineering and Management. So our format is very simple. Our speakers will make a short presentation about a topic and their perspective on the industry, and followed by time to answer your questions. If you haven't already, please email your questions to nacama@austin.utexas.edu, and Sandy will put the email address in the chat as well. So one of the students will win a 500 scholarship, which will be announced at the end of this event. So today I have the pleasure of hosting this webinar, and Sarah Slaughter is our speaker. And she is the founder and the CEO of the Built Environment Coalition, a research nonprofit. She holds BSc, SBSM, and I guess that's BS and MS, and PhD degrees from MIT. And Sarah provides sustainability and resilience support in critical infrastructure and sustainable systems for public and nonprofit organizations. Previously, she was Associate Director for Buildings and Infrastructure in the MIT Energy Initiative. Sarah served as advisor to the National Academies of Science, Engineering, and Medicine and other organizations to provide expert advice on technology, science, and public policy, and the relationship between the constructed and natural environments and their interaction with human activities. Dr. Slaughter is a member of NAE and NAC and is currently a co-chair of the Resilient America Roundtable in the National Academies of Science, Engineering, and Medicine. She recently served on the Green Building Advisory Committee to advise U.S. General Services Administration and the federal government on sustainability and resilience in federal facilities. She has an impressive resume. She was a professor at MIT in the Department of Civil and Environmental Engineering and at Lehigh University, where she conducted research in the NSF Center for Advanced Technology for Large Structural Systems. In her MIT research, she and her students created a unique microsimulation system to assist in controlling cost, schedule, and scope in complex projects and programs, and founded Mocha Systems, Inc. to commercialize the software. She was also a co-founder and lead faculty for the Sustainability Initiative in MIT School of Management. And previously, Dr. Slaughter was a visiting lecturer on resilience in the MIT Department of Urban Studies and Planning. Sarah, I don't know how you have done all you have done. And I'm so curious to learn more from you. With that, I'll leave the Zoom floor to you to present anything you would like to present related to your career or your work.
Excellent. Thank you very much for inviting me to be here. And I'm looking forward to the questions from the students and young professionals, because I think it's a lot of fun. I was realizing relatively recently, I graduated with my bachelor's degree quite a long time ago. And so it's always great talking to students right now. As you can tell from my resume, I like to start new things. And so one of the things that I'd be more than happy to talk to you all about is, what does it take to really take something for an idea and make it real? And everybody says, when I was starting a company and looking for funding, and the venture capital people would say, nothing new has happened in civil engineering in 2000 years. And I thought, you know nothing about my field. Things are changing all the time. And so it was fun to be invited to do this session on sustainability and resilience, because it just in the last, I don't know, 20, 30 years, there have been massive changes in how we think about sustainability and how we think about resilience, and the importance of the two of them and them working together. So really, when the concept of sustainability came up for built functions, built environments, it was really looking at efficiency, efficient use of materials, efficient use of energy and water, and it was really all about high efficiency. What's interesting is that it's really shifted over, both for public buildings as well as private buildings. It's really shifted over to high performance, right? Which is looking at, building health, the health of the people in and around, and other beings, the people and the other beings in and around the buildings, right? So we're now seeing a lot more on indoor air quality. We're also looking at issues of what does the building do in the environment, right? So shading, which may be an issue in your town or city, is now people are starting to pay attention to it. And so that's a really major change, because it's thinking about the near term, the long term, and the eventual end of those buildings and the decommissioning. So that's the closed cycle. So when you're no longer using a building, how do you either renovate it and reuse the materials, or do something else with it? So that's a change. The issue of resilience really comes out of, you've probably been to various cities and towns where there's a lot of very, very old buildings. Sometimes, if you're lucky, you get to go to a community where there's a couple of buildings that are several hundred years old, and they're still there. And people are still using them, and you can see windows disappearing and appearing, and doors appearing and disappearing, as people reuse the buildings in completely new ways. And so one of the things that communities are beginning to realize is that, especially with climate change and increasing demands on our built environment and how all beings interact with it, how do we think about buildings that can really last? And so that's the definition that I use for resilience, is the ability to accommodate change and disruption while maintaining critical operations and maintaining relationships, right? So communities that are resilient, you can tell that you can still get water, you can still have shelter. Even if there's a disruption, you may have to move around a little bit, but you still have those critical functions, those critical operations, and you still have ways for the community to keep in contact with itself. And so that's the real aspect of resilience. And the way in which they work together, they're not in conflict at all. The ways in which they work together, I was working with a public hospital, and I said, look, if you improve your sustainability, if you, for instance, increase the performance of your hospital in energy and water use, and so you use half as much energy and half as much water, you can survive for twice as long if there's a disaster. Mm-hmm. And that's the way in which sustainability and resilience can work together.
That was a great introduction, Sarah. Thank you so much. And since you ended with disasters and you mentioned disruption, so I'm going to start with Gus Castle's question. In the face of climate change and extreme weather events, how are construction practices evolving to enhance the resilience of buildings and infrastructure?
There are, well, like the, design and construction process, there are so many steps where if you take into account the climate changes and the need for resilience, you can incorporate it in. So from the first planning, where are you planning on building this building? There are a lot of communities I know that are now creating zones where they say, look, it floods every full moon, not just, every high tide, but every full moon, it's going to flood. We're not going to let anybody build there anymore. And that's an interesting change, right? So it's the whole planning of the community and where everything is. Then there's the design of the elements. If for some reason, for instance, if you're a fisher community, you may want to build someplace close to the water, but so you may want to build it in ways, for instance, having it up on stilts, so that when the water comes in, that you can still be safe, but you don't get flooded out every single time. I will point out that I was working with a port community recently, and they said, well, we'll just put all the houses on stilts. And I said, yeah, the problem is it's a saltwater the bay that you're on, and all of your infrastructure is underground. And infrastructure really doesn't like salt, and salt really doesn't like infrastructure. And you're going to have to worry about gas breaks and water main breaks and sewage breaks if you still have all of your infrastructure in the ground, if it floods regularly. And so it's this, thinking about not just the houses, but about all of the critical services that are in there as well. And then that's where the choice of materials come in. So for instance, if you look at along some of the major rivers for instance, in Europe, and there are communities there that have been there for several hundred years. And so every once in a while, the rivers flood. And so everything, like from the flooring to the walls to the apertures, are all made out of stone, because stone, washes off easily, and you can repair it, and you can go back and clean the whole thing up and reoccupy the building. And so it's an interesting one, thinking about all those parts together. And then you also have to maintain it. And we have a lot of infrastructure which was built in the last, 80 years, that didn't necessarily have the loving care and maintenance over the time period that it really wanted. So that, now I was talking to a bridge engineer, and I was saying, well, what if one of your design requirements for your bridge was zero maintenance for over 100 years? I love the Golden Gate Bridge, but they have to paint it. They start at one end and they finish, and then they start back at the beginning. And so it's an interesting one, thinking about all of those stages and incorporating in resilient materials, resilient design, resilient planning, and maintenance of critical operations.
Great answer. Thank you, Sarah. So I've been looking over the questions, and there are multiple questions related to 3D printing. So I'll read Sam Merifez, or maybe combine Sam Merifez with Sunday Akanji's question. How influential do you think 3D printing is to the construction industry? And does it seem like a reliable resource to create safer, more affordable houses? And Sunday is asking the question from another perspective. What promises does integrating 3D printing into construction operations hold toward infrastructure, sustainability, and resilience?
So there's a couple issues, right? So everybody thinks, oh, great, you just bring a 3D printer and you could just print anything you need. Well, there's a serious constraint on materials that you can 3D print. And at the moment, a lot of it is plastics. And if you're trying to reduce the use of fossil fuels, you can't come up with a plastic that doesn't have the fossil fuels in it. Even a lot of the other cementitious-based connections actually have binders that are plasticized. And so, you know, if you're trying to reduce the use of fossil-free or fossil units in all of your buildings or all of your infrastructure, your roads and everything else, it's not really going to help you much. One of the things that was also interesting is I was talking to an organization that was doing really big logistics and mobilization after a disaster, and they said, well, we'll just bring a couple of 3D printers down. And I said, okay, first of all, what are you going to print it out of, right? Because you're never going to be able to get that much of the standard 3D printing down to this disaster zone. Number two, you won't really want that building because it's flammable, right? And so it won't, those infrastructure units are usually flammable if they're made of petrochemicals. And I said, you know, you'd be a lot better just taking down a bunch of tools, like some hammers and saws, and learning how to use them.
What a concept.
Well, and you know, it's also, you know how to use a hammer and a saw and all the rest of the building tools. You can get a job anywhere in the world at any time. And so, you know, I actually started off as a carpenter. And, you know, if you know how to do basic things, then you, even if stuff is kind of falling apart around you, there's this feeling of, okay, I can cope with this. I can do this.
I love the fact that you started as a carpenter. That's fantastic. So I'll ask Hode Alam Rajabi's and Dayanara Vilastigos question. They asked the same question, more or less. Since we're talking about 3D printing, I'll continue along with the same emerging technologies related questions. So what are the most promising emerging technologies in the field of sustainable construction? And what impact might they have on the future of construction practices globally?
I think one area that is very, very promising is this spatial positioning. So on an active construction site, you can now have the equipment and people monitored so that you can make sure that people don't get run over by equipment. And that is a safety aspect is just absolutely phenomenal. And I think it is making a huge difference on construction sites. It decreases injuries and near misses and all the rest of it. And I think that as people really get used to those, it'll be more explicitly incorporated into the zero injuries or zero incident programs. And I think that that's an incredibly promising one. There's also a lot of stuff going on in materials and reuse of materials to make sure it's healthy, you know, both in procuring the used materials and then cleaning it so that you don't have any sort of particulate that people may breathe in. And that when you use it, you're using it in a way that actually creates a very healthful building. And, you know, I think the, you know, circular economy is very, very promising, but we have to be a bit more cognizant and a bit more careful about what that reuse step looks like. Because we're incorporating stuff into buildings that we didn't mean to incorporate because it wasn't identified at the right time. And I think that there's a bunch of stuff that's being done in terms of that reuse of materials and reuse of buildings that nonetheless protects the health of absolutely everybody and every living thing.
That's great. And you mentioned about the use of materials or recycled materials. David Abiola is asking, what are some cutting-edge building materials that support industry sustainability? And how may construction procedures be made more environmentally friendly to lessen their impact?
Well, so one of the things that's been a very interesting development is the use of electric vehicles on construction sites and for transport. Because one of the big issues is the emissions from, gas and diesel trucks and various other equipment that the poor workers have to breathe in. The other thing that I've been seeing is new ways of thinking about the dust on a site and reducing the dust, right? Because the dust in most older urban environments may have dangerous materials as well. And so there are a lot of ways in which a construction project actually affects everybody in the prevailing wind area. And so there are some interesting cases of construction companies, really thinking about it ahead of time because the community was so worried about the dirt, but it was also contaminated. And so in the process, the construction company came up with these ways of keeping the dust down and all the rest of it. And the worker medical claims dropped because it was bothering the workers as well as all the neighbors.
Can imagine. And
Yeah.
that was a great example. So I'm going to follow up with Jesutoba Ademiloye's question. Can you give us some notable examples or case studies where innovative technologies have successfully contributed to sustainable and resilient construction practices?
So one of the things that's going on right now is for a lot of government campuses, whether you're talking about the National Institutes of Health or National Institute of Standards and Technology, where they have a whole campus. And so they're thinking about a whole set of buildings all at once. And one of the things that's very interesting to see is rethinking the use of built environments. Right. So rather than saying, okay, this building will be an office building and this building will be, the structural lab and this will be the impact lab. And so what they're thinking of instead is mixing the functions. Pharmaceutical labs are doing this quite beautifully right now. And I don't know if you've ever had a tour of one, but you have the lab, the bench lab, and then you have a glass, no impact glass in between where the lab is and then where the office is and the research team and everything else, so that they can write things on the window, and it can be equations or it could be the steps that they're going through or whatever. And the materials in that pharmaceutical facility, for the windows, for the flooring, for the ductwork, so that you get really healthy air exchange rates with purification. And the purification systems that are being used now since COVID are really high performance and are using all sorts of new filters, which in some cases are also incorporated into masks. So there's lots of ways in which we used to think about construction materials, and then there were things like research, what you did for a research lab, or what you wore when you went outside and you didn't want to get a cold. And now there's a much faster mixing of the materials which are being used in all of the built environments as well as the specialty environments. And the energy generation, that was the other one I was going to talk about. That makes a huge difference when you're talking about campuses, right? So you can do energy generation on the campus, and that can really change up the performance of everything together. And then there's also water filtration systems that you can do on a campus. So every single drop of water that's there stays there and stays as usable water. It may not all be potable, but it can be quickly recycled into potable water.
Yeah, these are great examples. So following these examples, Jai Kishan Kansara has a question. So building sustainable and resilient infrastructure is crucial for long-term societal well-being. However, and we talked about implementing new technologies to enable sustainable and resilient infrastructure. Jaikishan is asking, implementing new technologies in construction often faces challenges like cost, lack of skilled labor, I apologize, and regulatory hurdles. So the question is, what are the most effective strategies for overcoming these obstacles and accelerating the adoption of sustainable, resilient technologies in the construction industry?
So there's a couple of very effective strategies and techniques that people are using. Right now, the General Services Administration, which is kind of the office landlord for the federal government, and the Department of Defense, which actually has the most built environments in the United States, are actually collaborating on a proving ground. So they don't call it pilots, they call it a proving ground. And they're all set up so that you have different technologies to accomplish the same end functioning side by side so that you can easily compare them. You're analyzing how much does it cost? How much energy does it use? How much water does it use? With what the performance is that you're getting out of it. And I think that will be the most effective way. There is a microbial fuel cell, which has been underdeveloped for a while, which is where you have a certain type of organism, a single-celled usually, and you just add some sort of a liquid waste stream, and you get pure oxygen out. And it is just so exciting. I've been watching this one for about 20 years now. And the real acceleration of the fuel cells, the microbial fuel cells, was when I think it was New Zealand or maybe it was Australia brewery said, set up your test ground using my brewery waste. And so it was the first time that they had pulled together examples of all of these microbial fuel cells, and they have them there side by side, and everybody can come and see. And they can see how everybody's, setting up the cell and what they're doing with excess generated heat, and whether or not they really function, or whether everybody's version of microbial fuel cells has the problem with the same waste stream or something like that. And it's a wonderful way of doing direct comparison in a place with a physical manifestation, so people can go there and they can look and I can understand. One of the continuing challenge is going to be, how does it work with everything else? In this case, you have an electric generation system, which is just absolutely fabulous. And we don't use, we use electricity assuming it's mediated, and that it, we don't necessarily have everything wired direct current. It's all alternating current, so that's our mediating approach. But there's a lot of materials that got used for bridge repair, for instance, in the 60s and the 70s and the 80s, which turned out to be incompatible with the original construction materials, or materials used in the construction. And so being able to think about how things work as a system, and compatibility over time. We're running into a couple of problems in some interesting locations now in terms of electricity capacity, which you may have heard about, and with everybody wanting an electric vehicle and houses going over to electric services only, but there's no more space on the system, on the electric system. And there's not enough space left in the ground to put in the new electrical lines, because it's all full of stuff that nobody ever decommissioned. So.
Great. And I'm going to shift gears a little bit. We talked about cutting edge materials, new techniques, emerging technologies. I'm going to get us back to more personal questions. So Iris Hernandez is asking, and I should probably have started with this question. What motivates you to be interested in construction?
I have always enjoyed, both building things and watching things being built. And I'm always so amazed going to places where, there's a facility or a building or something that has outlasted cultures. And so what really keeps me going in it is everything that needs to be done to improve the quality of life for every living being on the earth. And during with climate change and all of the dislocation and everything else that's going on right now, it's more urgent than ever. And so I was talking to a colleague, and they were saying, well, are you still going to keep doing this? I'm not young anymore. And I said, well, as long as there's a problem, I'm willing to try and contribute to a solution. So that's why I keep doing it.
That's great. And I'll follow up with Zahra Gorbani's questions. Can you please tell us about your career path and the challenges you overcome as a woman executive in the industry?
I think, there's I've had multiple career paths.
I noticed.
There's challenges in the academic community. And especially in ways of how you establish a credible voice within your specialty, right? And so that's one whole set of challenges. I've also started various organizations and run various organizations and worked with clients and all. That's a very, very different one. So when I moved from the university to starting up my company, a bunch of my students who had worked with me on the research joined me in the company. So we had a great set of co-founders. And we came out of a meeting with a very, very large client. We're trying to get them to try a new computer micro simulation model to control cost and schedule changes on really big construction projects. And my student said, Sarah, you got to stop. And I said, I got to stop what? And he said, you can't lecture the client. Right? Because part of the credible voice being a professor is having that, we're not going to argue this point. This is what I want to get across. You can judge the usefulness of what I'm giving you, but we're not going to argue about it. To talking to a client and saying, well, that's really hard to come up with what you want for zero cost, just to be honest. And so it's been interesting figuring out what the voice is there. Certainly being one of the few women CEOs, I started out my company over 25 years ago, and it's still running, which is pretty awesome. And it also has a woman CEO again, which is also really awesome. And, one of the things that's interesting is talking to clients to reassure them that I understand just how chaotic and difficult this project and lots of projects always are. You can't plan for everything because the world just doesn't work that way. And so, being a partner and an ally for the owner and for the construction team is a totally different voice from being a professor. And so I must admit, I probably would grade way too easy if I was in an academic setting now. But it's a lot more fun to work with the clients and the construction team and everybody else than to even be a professor.
That was another great answer. So Morgan Dawkins is asking, Considering your extensive background, both in both academia and industry, could you share a pivotal moment or a project that significantly shaped your perspective on the intersection of sustainability, resilience, and critical infrastructure? And how did this experience influence your subsequent work with the Built Environment Coalition?
I think one example of a pivotal kind of moment was I was advising one of the national parks, and it's on a coastal area, and it basically was a historic site, and it had been built. I mean, the historical activity had happened on shifting sand dunes, but they decided that they couldn't have that. So they planted the sand dune with dune grass so that it wouldn't move anywhere, which was fine, except it was no longer a sand dune. And the things that they had assembled around it were having problems because, of course, they were all flooding because the sand dune is supposed to move, right? It was a barrier island. And so I did some digging and was talking to the team, and I said, you know, you guys got bigger problems than whether or not your sand dune is moving. I said, you were on a saltwater, you were on a freshwater lens because you're part of a barrier island, and you're drawing down the freshwater lens so fast, you're not going to have water, potable water, and your community is not going to have potable water very soon. And they were like, no, that's not our problem. And I said, where do you get your water service from? And they said, from the town. And I said, and what is the town planning on doing? And the town said, well, if we run into problems, the national park is cut off. They got to bring in their own water trucks. And so it really shifted the whole framing for the team at the national park, because they were like, oh, we thought it was all about whether or not the sand dune was trying to move too fast. And now we realize that it's part of this whole system, and that we have to be more sustainable, right? We can't use that much water. We may not be able to use any water. And we've got to think about all of the ways in which we're vulnerable. And so this particular national park is very well loved by its communities and by, people who visit it. And so it had to be both a sustainability and a resilience framing in order for this park to know that it's got better chances of surviving in the next couple decades.
Wow, that was a great example.
And that's an example of the kinds of projects I do with the Built Environment Coalition. The whole idea is that it's kind of a research and education nonprofit. And so one of the things that I did was fairly early on migrate towards public agencies. So city, county, state, the various, and then the national and then the international, because those are the organizations where everybody in a community cares about those facilities, right? Because they are offering often critical facilities, which could be governance or finance or medical care, and with nonprofit agents or nonprofit organizations. And so which are often more cultural continuation. And so I usually focus with public and nonprofit.
Great. So we have only 5 minutes left, and I'll try to squeeze in 2 advice related questions. So Golnush Abdul Lahzadeh is asking, given your extensive experience in sustainability and resilience within critical infrastructure, what advice would you offer to aspiring construction engineering students like me who aim to integrate sustainable practices into the future projects?
I would suggest field experience. I mean, you know, starting off as a carpenter, what else would you think me I would say? But you know, you have to be on site sometimes to understand how things interact with each other and to see what's possible. And so I really think it's important to get on site, on a real site, you know, as often as possible, and really listen to the people who have been in this industry for a long time.
Mhm.
And when we created our micro simulation model, my students went out and interviewed trade specialists as they were putting stuff together, and the trades loved it and my students loved it. And so that I think would make a really big difference. And then work for companies that are thoughtful.
Yeah, those are great examples or advices. Um, those were the question. Previous question was related to sustainability and resilience. This one is related to, and it's Anthony Hinonjaza's question, related to coming like fresh out of college, right? What is some advice or something you wish you knew going into the construction industry, specifically for a first year fresh out of college student?
This is going to sound funny, but I think you all will get it. It's being humble. You know, you come out and you've got a degree, you've got an engineering degree, and still doesn't mean anything. You still couldn't find your way across a construction site. And so I think being humble and asking questions and asking for clarification and asking the why. Why do you do it that way? And
Curiosity, right?
being curiosity and being honest about not knowing. You know, is for instance, if you've been doing structural steel and you've gotten a lot of good background on structural steel in all your classes, but you really don't know about cast in place concrete as a structural system and what are the actual construction processes, right? So what's the cure before you strip the forms, and you know, what's the density of the reinforcing bars, and how do you check the rebar tie and placement and all the rest of it. And so, you know, those I think are important aspects, is always ask questions and always be humble enough to say, wow, I didn't know that before. So ask good questions.
So that's a good advice for everybody. And one last question. If you could snap your fingers and change only one thing in the construction industry, what would that be and why?
I think what I would change is people's perception of the construction industry, so that everybody could see an opportunity and excitement. They could really appreciate the built environment that everybody else has built, and they see ways in which it could get better and that they could contribute to the better. That's what I would really love, because you know, we are so low on engineers and construction people and everybody else. So we really need everybody to see the opportunity and the excitement.
And both civil and environmental engineering are very magical fields, in my opinion. So of course I'm biased, right? One builds the built environment, the other one protects the nature, our planet. Well, Sarah, this was wonderful. Thank you so much for spending an hour with us. We have a winner, and the winner is Raha Haji Shashrafi from the Catalog University of America. Congratulations, Raha. And again, thank you, Sarah, so much for sharing your experience and expertise. And before we say good night, we would like to say a special thank you to our sponsors again, University of Florida Rinker School of Construction, Arizona State University Dell Webb School of Construction, and the University of Colorado at Boulder Construction Engineering and Management. And we look forward to seeing you at our next webinar in February. Thank you again and have a wonderful evening.